Hello everybody, it's Mrs. Braband. I am just going to continue with our Unit 3A Target Summary Hyperdoc so we can do the video for Target 2. This is on multiplying, and if you notice, problems 1, 2, and 3 look a little different than 4 and 5. So there's going to be, the fundamental rules in problems 1, 2, and 3, which is what do you do with those exponents. But when we get to 4 and 5, because it has the addition and subtraction signs, we're going to do a little bit of a combination of an old rule that we used to know for distributive property with this new rule of powers. So let's just start with number 1. I like to rearrange, put what looks alike together, so that when it comes to simplifying, it's easier to kind of see. Basically, whatever the number is, we do like we've always done for a number of years. We just multiply those. But for the powers, what you're literally doing here is you're counting what you have. So I have 2 things, and then I have 3 things, so that means I have 5 things. And in the y's, I have 5 things and then 1 thing, so that means I have 6 things. So in other words, what you're doing with your powers is you're essentially, because you're counting, is you're adding. So that's the power rule for multiplication. Again, you don't have to organize it in order, but it does kind of help, especially when you've got things like this negative number going on. Because what you want to see is when you add those powers, what's going to occur. So again, you don't change the rules for what's in the beginning. We've been doing that for a long time. That's positive 35. But here you want to see this as counting. So you're going to write your addition up there if you need to. You might be able to do it in your head. But I like to write it out just in case, especially if you have numbers. So the 35 stays. We finished that. But now the x is a 4 and the y is a 2. So even though you felt like you were subtracting, the rule was really just counting what you had. Now this one looks a little bit different, so we could do this a couple ways. One way is we could exactly take care of that power of 3 and write it out 3 times. And when you do that, now you've just made the problem look like the ones above, and then you follow your rules. 2 times 2 times 2 is 8. Well, let's count these x's. 4 plus 4 plus 4 is 12. 5 plus 5 plus 5 is 15. That is one version on how to do it. The other way, and I'm going to write it over here, and then I'll do the other side and get the page. The other way to do that one is what you could do is you could distribute the power to each piece, each piece, each piece. And then you have 2 to the 3rd power. We'll have x to the 4th to the 3rd power. And you'll have y to the 5th to the 3rd power. And as you can see, you're going to end up getting the same exact numbers, but it kind of looks like you have a different rule. So we have 1 power in, 1 power out. The shortcut for that is multiplication. But if you were to write it separately, like we did earlier, you'll see that it's really just multiplied 4 with 4 with 4. So I don't care which rule you use for that. I'm going to go to the other page to do the other 2, because as I said, if you take a look at both of these, you've got monomials being multiplied. Polynomials, meaning 3 times, sorry, let's get this out of the way so you can see what I'm talking about. 3 terms, multiplied by 3 terms, you're going to end up getting 9 things possibly there. And then here you've got binomial times binomial times binomial. So we've got a lot more to go here. I'm going to go to a different page for each. This is just an exercise truly in being organized and showing you distributive property. Trying to maybe underline what looks alike so that when you combine like terms, it's not so difficult. It's not that it's super hard. It's just that it's staying patient and organized. So I'm going to do distributive property here like I always do. Some of you call it FOIL. First times first is 6x squared. Last times last is 2y squared. I've got a minus 3xy and a plus 4xy in the middle. So it looks like we have 6 squared, or x squared, plus 1xy minus 2y squared. That is nothing new. We've been doing that for a long time. But if you tack on this other binomial out here, what you really end up seeing is that you have 2 pieces. Now you could do this in a lot of ways. You do the 6 with everything, the xy with everything, and the 2y with everything. Or you could do it in reverse order. I like reverse order because it just makes more sense to me. So I'll take the 4 with everything in the front, And again, this is just distributive property. And then I'm going to take the 3y with everything that I see in front. And I'm just going to be super slow and cautious when I multiply because I'm going to have to combine my terms when I'm done. So let's go to the top and distribute like normal. 4 with the first part is going to be 24x to the third. The front with the second part is 4x to the second y. And the front with the third part is negative 8, 1x, and 2y. So not difficult, just be cautious. Now we're going to go down and play the same game here. So this piece is going to go with each, with each, with each. So let's get going. And then I'm going to try, as I start hearing things sound alike, I might try to organize them and stack them up on each other. That might just keep it in a good order. So 3 and 6 is 18x squared y. 18x squared y. I've heard that before. So I'm going to put that underneath here, 18x squared y. I recognize it looked like the other one, so I ordered them. Then we've got 3xy squared, positive 3xy squared. Luckily, as I'm writing in order, that does match this one, so that's great. Now we're going to do 3 of the last one, and we get a negative 6y to the third. So I've got it organized now so that when it's time to combine them, they're all in nice order as I add down. Now I'm adding like terms, so the like term is this. You don't mess, when you're adding, you don't mess with powers. You're saying 4 things plus 18 things is 22 things. You don't change what the thing is. And then this is negative 8 plus 3, so that's going to be a negative 5 of whatever you're counting. Again, when you're adding straight down, you don't mess with the powers. But when you multiply across, you do use your power rules. And then this one doesn't have a partner, so it goes along. And there is your answer. Again, distributive property, be careful with your powers, and be careful with combining like terms. It's not that the math is really overcomplicated, it's just that the complication lies in the organization. Let's do that last one. This looks like it's kind of the same thing, but in essence it's longer. So I'm going to take the first piece times the whole second thing. I'm going to take the second piece times the same thing. And the third piece times the same thing. And I'm just going to go really slow. And as I look at this, I kind of recognize that there's probably not, do you see how everything in front is super different? That means all my numbers are going to be different. I'm probably not going to be able to combine like terms, but we'll look for that. First times first, 8x to the fourth. Second part, 4x to the third. Last part, plus 2x squared. Again, it's just distributive property in each row. Go down to the second one. We're going to get ready for that. That's a 4 with a negative. There's 3 x's and 1 y. I'm not stacking them in order now because I just don't think it's going to help, but I'll look for it later. Second piece is positive now. There's a 2. There's 2 x's and there's a single y. Here, there's a minus sign and an xy. So I'm trying to use my multiplication rules for the powers, but it doesn't look like anything's combining like terms. Let's go here. 12. There's an x squared and a y squared. Let's go here. There's a negative 6 xy squared. And let's go here. There's a 3 y squared. So I don't think, let's double check. Is there anything that has a single fourth power? It looks to me like everything is different, but let's just check. Nothing with the third power, nothing with a single x. Is there a 3 x's and 1 y? 3 x's, 1 y, 3 x's, 1 y. There's not a darn thing matching, so let's count our terms. 1, 2, 3, 4, 5, 6, 7, 8, 9. That makes sense to me because they have 3 different things times 3 different things. That's 9 different things. So, merciful heavens, this is just a long exercise in being cautious with multiplication, and I'm just going to write it out. I am not even going to worry about standard form because what is the point? We can't do anything in the standard form. It doesn't really tell us anything right now on this long one. So let's just, darn it, write it out. This problem is probably one of the reasons why people don't really love mathematics, because it's just, can you be thorough? But again, there are some people who are really attached to organization, and they love these problems because it's very orderly. Find your fix and just be cautious. That is it for Target 2. Thank you.